Okay, so we're on section 6.1, and I'm looking at example from page 291. Determine the non-permissible values in degrees for the equation secant equals tan over sine. Okay, so first let's take it back maybe just to above the example. I can't see it on this screen, but you'll see that there are things called reciprocal functions. Okay, and these are things we know already. We know that cosecant is the same thing as 1 over sine. And we knew that sine is the same thing as 1 over cosecant. That just means they're reciprocals, right? So they're the opposite of each other. That also means that secant matched with cos. And that also meant that cotangent is the same thing as 1 over tan. Or you could say tan is the same thing as 1 over cotangent. Okay, those are called reciprocal. I said functions, but that's not right. They are reciprocal identities or properties. Okay, the other one that's important, and we'll know a few of these aren't something you have to memorize per se. We know it already, but they do show up on formula sheets. The other one is quotient identities. And all quotient means is division. Okay, and we've talked about these ones already also in chapter 5, because we know that tan is the same thing as sine divided by cos, or sine over cos. We talked about that before. And so then if cotangent is the opposite of tan, then cotangent should be cos over sine. Okay, so what we need to do, since we talked about those reciprocal and quotient identities, we're first going to start with restrictions. So we know restrictions from before are things that you can't have in the bottom of an equation or under a root or situations like that. So the same thing goes for A here. It says determine non-permissible values in degrees for the equation secant is equal to tan over sine. Okay, so we need to identify things that would make a problem in this equation. Okay, so what we're going to do is, if you look at your unit circle, and we look at, first let's look at this secant part. Okay, so we know secant doesn't show up on your unit circle, but what does show up on your unit circle? Sine and cos, right? And tan, because tan is sine and cos, but secant is the same thing as 1 over cos. Okay, so we can think of secant as everything that's 1 over cos. So what wouldn't we want cos to be here in the bottom? 0, right? So you need to look on your unit circle and see where is cos 0. Cos is 0 at, what's that? Pi over 2, which is, and since we're talking in degrees this time, we'll talk in degrees. 90. So cos is equal to 0 at, what did we say? 90 degrees and 270. Okay, so this is the start of where we're going to start looking at our restrictions, okay? We'll also look at the tan piece, and we'll look at the sine piece. Okay, so tan, we know was undefined because we drew those before, right? We just finished in chapter 5 drawing tan graphs, and where were they undefined with the dotted line? Pi over 2, which is 90, right? So they're undefined at 90 degrees, and it's also 270 if we kept going, okay? Okay, and then there's also sine in this part of the equation. So we want to know when sine is equal to 0. because sine happens to be in the bottom of this equation, and we don't want that to equal 0. Okay, so where on your unit circle is sine equal to 0? 180? Is that what I heard? 0 and 180? Okay. And 180 degrees. Okay, so now we've established that it's like cos is 0 at 90, 270, tan is 0 at 90, 270, and sine is 0 is 0 at 0 and 180. Okay, so the three sets of non-permissible values for the equation can be expressed as, if you notice, these are each going up by 90 if you looked at all of them together, because it goes 0, 90, 180, 270. Okay, so we can just express those as, you can say non-permissible values of, is it secant tan over sine is, oh, and I'm running out of room, is this is the angle symbol, cannot equal, and we'll say 90 degrees n with it. Okay, so I'll move it over so we can see it a little better. We cannot have an angle, so not equal to 90 degrees n. N meaning, like, if n was 1, it would be 90. If n was 2, it'd be 180. 90 times 3 is 270. So it's going by 90s every time. Okay, and if you really wanted to, you could list them out. You could say 0, 90, 180, 270. But then it would have to be dot, 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 because it's going to continue. Okay, we're moving to still example 1. Part B says numerically verify that the degree, 60 degrees, and this are solutions of the equation. So we're trying to prove that 60 degrees and pi over 4 are solutions to this equation. Okay, so let's separate it into sides here. Let's do left side, right side. So left side is just secant. Okay, and we know secant is the same thing as what? 1 over cos. Okay, so secant is the same thing as 1 over cos. So what is our value of cos at 60 degrees? Like, what is the point? It's a half, right? So this is like saying, sorry, I should switch this to a 60. If I'm at 1 over cos 60, if I actually went on my calculator and went cos 60, I would get 0.5. But looking at the unit circle, we get a half, right, which is the same. And so it's 1 over 1/2. Okay? And there's nothing worse than a fraction over a fraction. So we flip it to fix it here. Okay, so this will cancel, and we have 1 times 2 is 1, divided by 1 is 2. So secant at 60, our answer should be 2. Okay, that's the left side, and we got to see if it matches the right side. Okay, so if we go tan, okay, so here's the right side. And we go tan 60 over sine 60. Okay, so do we know what tan 60 degrees is? What's that? Find what it is. Well, and you probably want an exact value. Okay, so if we want to find out what tan 60 is, you take what sine on the unit circle is, and you divide it by what cos is on the unit circle. And since we had fractions over fractions, we multiplied by the reciprocal, and we ended up with √3. This also could be done using our special triangles, right? Because we know one of those triangles is 30, 60, 90, right? And the special triangle looks like, if we're using our special triangle, you were going from the 60 and you're saying tan. Tan is opposite over adjacent. Opposite is root 3 over adjacent is 1, so it's root 3 over 1. So now we know that tan 60 is root 3, and we can use the special triangle just like we did before to find sine 60, or you can look at your unit circle. But if I was using the special triangle at 60, sine is opposite over hypotenuse. So it would be root 3 over 2. And I have fractions over fractions, so I'm going to flip and multiply. So these will all be gone, and I can cross those off, and I'm left with just 2. So these sides, this side equals 2, this side equals 2. So we know that this equation, or 60 degrees, is a solution to this equation. Okay, so we're still on example 1b, but we're looking at, does it work for pi over 4? Is it a solution? So basically we're checking, is this going to give us the same answer on both sides, meaning it is part of the solution for pi over 4. Okay, so we're going to start off the same way. We know that secant is the same thing as 1 over cos. So we're initially looking for 1 over cos pi to the 4. If you wanted to change this pi over 4 to degrees and give her that way, that is a way you could solve it. I'll solve it using it as radians, but know that if you want to get rid of it and just figure out what this is as a degree, then you can do that. Okay, so we have cos pi over 4. If you look on your unit circle, what is the point where pi over 4 is cos? Root 2 over 2. Okay, so I'm going to be writing it as root 2 over 2. And remember, if it's root 2 over 2, secant's the opposite, so your answer is actually going to be 2 over root 2. Because I would be getting this fraction out of the bottom by multiplying by the reciprocal. And I would end up with, whoops, and I would end up with 2 over root 2, which isn't really great to leave like that because it has the root in the bottom. So we would multiply by root 2 and root 2. So in the top you get root 2 over 2, and root 2 times root 2 is root 4, which the root of 4 is 2. So when we break it all down, we end up with root 2. That's just the left side. So if we try to make it work in the right side, our point is we should work all the way through and we should end up with root 2, meaning that it is a solution to both sides of the equation. So our other side of the equation was tan, we'll put pi over 4, and sine pi over 4. Okay, so if we needed to figure out what pi over 4 is in tan, you'd have to look on your unit circle. Tan is hard to look at on a unit circle because it doesn't show up. You always have to think of sine over cos. So it might be easiest to figure out what is pi over 4 as a degree. So if I multiply by 180 over pi, those will cross off, and I go 180 divided by 4, I get 45 degrees. That means I'm dealing with the special triangle 1, 1, root 2, because this is the 45, 45. Okay, so if I'm looking for tan 45, which is the same thing as tan pi over 4, tan is opposite over adjacent. So it's 1 over 1, which is 1. Okay, so our top is 1 for tan 45, and then we can assume, since pi over 4 is still 45, what's sine 45? You could look on your unit circle, or you can use the special triangle and go sine 45, so opposite over hypotenuse, 1 over root 2. Okay, so 1 over a 1 over root 2 is going to end up as a root 2. And both sides of the equation's equal, so therefore it is a solution.